Okay. Hello, I am Alex Shelley, and this is Alex Makes a Game. In this stream, I am making a game in Unity and broadcasting it. I'm also uploading it to YouTube. I'll post to my YouTube channel somewhere. Let me see here. Oh well, actually I'm not logged into it, but I will post my YouTube channel somewhere in here. And if you want to view the GitHub for this game, it's right here. So anyhow, this is not a tutorial, by the way. If you came here looking for a tutorial, I'm sorry, you're in the wrong place. This is for entertainment purposes only. So on that note, let's get started. Last time, we started a first-person game, and we added the fog. The fog continually gets closer and closer and closer to the player until it reaches the minimum distance. Let's just see what that minimum distance is really quick, actually. There it is. It's pretty close. So yeah, it's pretty hard to see now. And when you collect these things, I believe they're called lamp oils, the fog gets pushed further back. And that's all we have so far. I also reviewed my general process for making a level, where I just showed off the Pro Builder plugin. Anyhow, today we're going to be adding the first enemy. And it's going to be a fixed 3D thing, just like the lamp oil. So it will not have a model, it will only have a sprite, like in Doom. First things first, let me make sure that, yes, okay, we do have that there. So I'm going to create a game object, and we'll call it, what are we going to call it? Dummy enemy prefab. And here he is. And I need to add a component. I think the first thing I'll do is I'll make the visuals for him. I'll make the sprite and make him render. So I'm going to add a billboard behavior and a sprite renderer. He doesn't have a sprite yet, so let's make one. I have no clue what the size should be. Let's fill it with transparency, though. Man, let's make him twice as high as he is wide. And I'll add a background layer really quick, just so I can see myself drawing. I'll delete it later. Get it? Later? Never mind. Actual image. Okay, get out my trusty Wacom drawing tablet here. Set everything up the way it needs to be. And I'll give him a head, I guess. Oops. It's just going to be like a rough drawing of him. We're just going to get something playable as soon as possible. That's our goal. And then later we can make the graphics and stuff look better. And hell, later we can worry about the balance. Oops. Yeah, we don't even need to worry about the balance of the game just yet, because it is just the beginning. In fact, why am I even going to this much detail? This is all the detail I really need. Beautiful. That's a terrible nose. Okay, well, this is about as much detail as we need to get for now. So let's delete the background. Okay, I gotta use my actual mouse here. Delete the background, merge this down. Oh crap. You won't be able to see that since it's all transparent, so white. Ah! Just plug this hole up. We're gonna do some hole hunting and make sure we get all the holes. Ah! Who knows where that other hole is? I see where it is. Right here. There we go, there we go. And part of him will be transparent, whatever, it doesn't matter. It's just a placeholder image. And where am I going to export this? Bug Mansion. Oops, that's not where I wanted to go. Assets, sprites, dummy. Oh, actually, before I export this, I'd better crop it. Or, actually, no, I said he would be... these are going to be the actual dimensions of him. So, let's just do that. I'm going to keep these dimensions. I'll change the actual proportions later, but this is... Okay, now layer auto crop. Did that auto crop it? No. Just crop to the image size. There we go. Now we export it to assets, sprites, and we'll call it dummy enemy. Actually, I gotta have the same naming convention, dummy enemy. All that stuff, sure. Now back in Unity. I am recording and broadcasting. Yes, I am. Okay. Back in Unity now. We will... Oh. First off, we gotta change the sprite to actually be a sprite and not a texture. Just like last time. And now, dummy enemy will have his sprite. Poof. And he's kind of floating because he doesn't have a rigid body or anything like that. And I don't really like how he's rotating. I don't like how he's rotating vertically, you know? How if I get underneath him, he looks like this. Actually, I should probably be making this screen bigger. So it's more obvious on the stream. But yeah, I don't like him sort of bending over like that, so I'm going to modify the billboard behavior script. Say public bool. Let's see here. I'm going to set it to... What settings am I going to name it? Call it billboard X and public bool billboard Y. And this is going to create a thing in the inspector to actually it's going to create two Boolean values in the inspector, at least it's supposed to. There it is. And they don't do anything right now. I got a code for that. Actually, you know what? I always want to billboard the Y. So let's just have it be billboard X. I'm just going to tack on some code right after I billboard it. that, oh, what is it? What does it do? It will get rid of any rotation on the x-axis if billboard x is false. So if billboard x is false, get rid of x rotation. So if not billboard x, what I could do to do this is just change transform.forward. Oh, well, yeah, that should work. Although that might not, oh yeah, okay. That won't work. Instead, I won't explain why, but what I just did was kind of nonsense. Or, well, no, it wasn't. Yeah, I'm going to just change. I'm just gonna change the Euler angles actually. Transform dot local Euler angles, could be global, but I don't care. Equals. Here, if I want to edit it, vector 3 Euler equals transform dot local Euler angles, then Euler dot x, is it? Yes, x equals 0, transform dot local Euler angles equals Euler. And now that should stop it from happening. And I'll explain exactly what I just did in a second, but yeah, it works now, as you can see. It also applied it to, it also applied it to the lamp oil. That's because lamp oil right here does not have billboard X checked. And I'm not sure if I want it to billboard on the X. For now, let's just say yeah. And it's called a prefab, but for some reason I didn't actually make a prefab out of it. So let's make a prefab out of both of these. Okay. Now, let me explain. Before I move on, I feel like I should explain vectors. I know I said this wasn't a tutorial, but let's face it, I'm going to be using vectors a whole lot in this thing, and it'll be much easier to follow along if you understand vectors, at least somewhat. So I'm just going to do a quick little rundown. Where's paint? I'm going to do a quick little rundown. Okay. So a vector is just a collection of 3 variables, x, y, and z. It's 3 variables, x, y, and z, all grouped together into one data type. In Unity, it's called a vector 3 because it's got 3 components to it, x, y, and z. But Unity also has a vector 2, which only contains x and y. And the point of a vector is to store a coordinate, or a point in 3D space. I need a bigger eraser. And the shortcuts are not the same as they are in GIMP. Oh crap. Brush size, there we go. What? No, that's not an eraser. I did not prepare for this class. I'm sorry. I'm sorry for all the erasing. Okay. Drawing again. So a vector is just a quantity that contains 3 things. And the cool thing about vectors is you can add them together. So if I have a vector that's where x is 4, y is 7, and z is 0, I can actually add it to another vector, like say 6, 3, 10, And the way you add vectors is you add the corresponding components together. So you'd get 10 here, and 10 here. And you can subtract them just the same way. And the last thing you can do that I'm going to talk about with vectors is multiplication. You can multiply a vector by a single number. This single number is called a scalar, by the way. And it's called that because it scales everything in it. When you multiply a vector by something, like 2, 2, 1, you end up multiplying all of the components by that scalar. So this would be 8, 8, 4. And the reason we use vectors, like I said, is both to store a position, so every object with a transform dot position has a vector that stores its position, and we also use vectors to store velocity. So like every frame, we would add a vector multiplied by the time to the position. That's what I did last time in the fog behavior. But what I did right here, this does not represent a point or a velocity. It instead represents a rotation, Euler angles to be precise. And here, when we're doing Euler angles, when we're doing Euler angles, we basically just have a vector that stores something like 45 degrees, 0 degrees, and 3 degrees, because that's how you represent a rotation in 3D space, because I could rotate this by like, 90 degrees, and that's not the same thing as rotating it this way by 90 degrees. So we use a vector to specify exactly how we're rotating it. Anyhow, that's the end of what I just did. That's the end of the tutorial part. Now we're moving back onto actually doing things. I hope that was clear. So what was I just doing? I made it so that he does not billboard on the x-axis, which is good. But now I need to make him behave like an enemy. So to do that, I'll add... No, not a new script yet. We will add a new script. What was I doing? I'm going to add a rigid body, I think. Although there could be one that comes with... Yeah, let me see what scripts I already have, actually. Standard assets, characters... This is a third-person character. Let's make him a third-person character. And he uses the rigid body. Let's get rid of the animator, because that only works with 3D models. He is not a 3D model. What the heck? Third-person character depends on it. Okay. Looks like I'll have to modify this. And I did not write this, so you know what? I will not modify. Yes, I will modify it. I need to make it so that it no longer depends on the animator component. So I'll just Control F for animator. And remove all references to it. In fact, I'll just delete this entire function, method, whatever. Oh, wait a minute. They're using the animator to check if it's grounded. Okay, new plan. I am not going to touch that script, and instead... Let's remove. Why won't it remove? Okay. Instead, we're going to add a first person. Oops. A first person character, because he will not have an animator. Rigid body first person controller, to be precise. Just like the one we used on the player. Except, oh, wait a minute. He doesn't have a camera. That shouldn't matter, though, right? Yes, it does matter. Looks like I'll need to write my own controller for it. That's fine. In the meantime, oh look, they actually made the collider the correct size. Anyhow, I really don't need any of these scripts. I really just need, for now, the rigid body. And as I stated last time, the rigid body is just... Ooh. Wow, he's not stopping, is he? The rigid body just makes him affected by physics. Why wasn't he stopping? Shouldn't he have friction? He's also not being knocked over. Why isn't he being knocked over? Oh, he's not being knocked over because of the billboard script, I bet. Yep, see, now he rotates and stuff. So yay, the billboard script did things. It's serving two purposes now, actually. So now it will not rotate when I don't want it to. And it will face the player. So next I'm going to actually code his AI behavior now. Or, yeah. I'm going to actually make a generic rigid body car motor. And this will apply to anything that's like a character motor. So anything that will move with physics, but also walk and jump and stuff on its own volition. So, first thing, actually, you know what? I don't need to do that. Or, yeah, I'm going to do it. First thing I'm going to do is make an interface for it, so that other components can turn different controls on and off for it. So, vector 3, input direction. There's a vector again. This one will store, it will store the direction that that it's trying to move. Does that make sense? And what else? Jump button. If it's true, then it will jump. Actually, you know what? Since it's not going to be the player doing this, maybe I don't need to have the jump button. Maybe I can just have a function that makes the enemy jump by a specified height. That actually sounds better. Or, you know what? Since it's not being controlled by the player, just public float jump height. And then every enemy can have a different jump height. Alright, so first thing it's going to do is during the fixed update. Fixed update is just like normal update in that it happens every frame, except it doesn't actually happen every frame. It happens every physics update. See, the physics and the graphics run at different frame rates. Does that make sense? Basically, anything that happens in fixed update, time.delta time, will be the same regardless of your frame rate. Fallout 4 does not do that, and that's why it has physics errors at variable frame rates. Fixed update is supposed to help avoid that. Anyhow, every fixed update, we're going to check if it's grounded. So bool is grounded equals false, and then we're going to have a separate method update grounded. And to check if it's grounded, all we need to do is do a raycast slightly below. So private float ground check dist. Maybe even less than that. And what a raycast is going to do is it's going to draw an invisible line underneath our enemy, and then it will check to see if that line intersects any solid colliders. So this guy right here is a bad example. This guy, for instance, he is above the ground, and he's got a short raycast. Ignore what that looks like. I'm sorry. I should really make that look like... I really shouldn't make it look that way. Here. Here's our guy, and there's the raycast. It is not intersecting this box, so grounded would be false. And here's our guy. The raycast is intersecting with the box, so grounded would be true. And we're doing that so that he's not able to jump while he's in midair. There's no double jumping here. So, what was I doing? And make it so that we got to do a raycast. That's right. Actually, no, we can just say grounded equals physics.ray. It's not giving me... Hang on. Any physics... I forget the exact syntax. And for some reason, it's not giving me all of my options. So, origin, direction, max distance. Okay. Where is code? There it is. Just going to pass in the point, transform dot position, and then transform dot down. That's the direction we're going in, and the max distance is going to be ground check dist. I could have swear I remembered using a more complicated method to do the same thing. Oh well. So now in fixed update, we're going to update grounded. And now we're going to make him jump. So if grounded and... Oh, wait a minute. No. I'm an idiot. I forgot. We got rid of the jump button variable. Instead, we're just going to have... let's make this private so I don't accidentally call it. We're going to have a method just called jump, and it will void. And it will jump if grounded. If grounded, and then we need to know the jump height. Or we need to know the velocity to add to the rigid body. Well, I should probably get the rigid body. Require component type of rigid body. Where should I put it? Put it right here, private rigid body. Save it. Maybe saving will make my autocomplete start working again. Anyway, I gotta get a reference to that component, the rigid body component. Get component rigid body. Ah! Autocomplete, why you do this? Let me make sure I'm spelling everything correctly because... Okay. This is actually supposed to be vector 3 dot down. So now do I... Well, we need to fix all these errors. What? Okay. That's an easy fix. Vector 3 dot up times -1. Perhaps I should explain what vector 3 dot up is. Vector 3 dot up is just a vector where x is 0, y is 1, and z is 0. In other words, okay, well, Who's Your Daddy just updated. Anyhow, what was I saying? The vector is going to look like this if it were an arrow. And when I multiplied it by -1 right here, I just ended up making it 0, -1, 0, which in turn makes it point downward. Why did I do that? Well, I need to specify which direction the raycast is moving. And I also need to specify where the raycast starts, and for how long it goes. I'm sorry I didn't explain that earlier, when I was actually doing this. I'm kind of nervous on stream, I guess. Anyhow, so does that fix all of the errors? Not if I don't save. Now that I've saved, everything is error-free. So now if it's... So I'm just going to say to do find correct jump force. You know what? I don't even need to specify the jump height. I can just say jump force, then I don't need to calculate anything. Just say rigid dot. Well, okay, yeah, it's not giving me options, so Unity rigid body. Gotta look at the documentation. Add force. So rigid dot add force, and it's going to be in the direction of vector 3 dot up. It's going to be an up force. And I actually need to multiply it by the jump force. There's vector multiplication again. And actually, I think that was all that's required. Yep, okay. We won't be able to test this until I actually make the dummies AI. So I'm going to do that right now. So let's make a folder. What am I going to store in this? I'm going to store enemies. Dummy enemy. Behavior. Reload all. I should probably actually do a git commit just to save my progress so far. So I'm going to need to save this too. Yes, sirree. What is it? Dummy enemy. Started on the dummy enemy. That's what I'll call it. Git is a tool that allows me to upload my code to GitHub. It also keeps track of many different versions of the project directory. So this entire folder is getting backed up constantly by Git, which is really useful if I make a really bad mistake and I need to undo something. So it also lets me add a message to it, which helps me organize my thoughts. Anyway, now we've started on the dummy enemy behavior, and all he's going to do is, oops, he's just going to jump constantly for now. Require component type of rigid body. Oh, now it lists Unity stuff. Now it does the autocomplete correctly. Actually, I don't even need to require rigid body. I just need to require rigid body car motor. So private rigid body character motor, and then in the awake event, we're going to obtain a reference to that motor just so we can talk to it. Let's add some organization. Oh, hang on. I'm going to do this in fixed update because I think calling add force during normal updates is bad practice. I'll have to look that up later. But now I can just say motor.jump. And since I'm constantly jumping, now our dummy enemy should keep jumping. Well, he should. Oh, jump force is set to 0, that's why. So now that's set to 200, he should be jumping high into the air. I said he should be jumping high into the air. Huh. Strange. Let's look at the rigid body character motor. Maybe it's not grounded. Or actually, I don't even need to insert anything right there. I just need to go into debug mode and check to see if it's grounded. Aha! According to this, it is not grounded. Actually, where is his transform.position? I see. Okay. So I need to shift the, yeah, I need to shift the raycast starting position down by half the size of the collider. So transform.position plus vector3.up times what am I multiplying it by? I'm going to multiply it by the height. Half the height. So collider. I actually need to get the capsule collider. Actually, you know what? Who says it needs to be a capsule collider? Maybe all colliders have a height. Call collider. Oops. And require it as a component. And if this doesn't work, I can replace it with a capsule collider. So anyhow, times collider, and it doesn't show it as an option, but that doesn't matter. Collider dot... Ah! Come on. You, right there. Just... I want your options. What? Name collider does not exist in current context. Well, that's just flat out wrong. Because collider is clearly right there. Oh, crap. I named it wrong. Wait, so collider already is a variable. That means I didn't even need to get it. It's times collider. The hell? This dot collider? No. Alright, well, it looks like I am making my own collider variable. And I'm going to rename it to my collider. Don't you tell me that doesn't exist! It absolutely does exist. You... Look at that. I got the variable right there. Okay. Maybe I need to save. Maybe that'll fix it. No? If I copy and paste it directly, will that fix it? What the... No, okay, what? And now it's saying ground check disk doesn't exist either. So that's completely wrong. So maybe if we cut this and paste it. Huh? I'm so confused. Okay, if I remove this, does it work? Like, is it just having trouble parsing it because it wasn't finished? No? What? Something's very wrong. Are all of my semicolons not semicolons. Aha! Found the problem! I was missing a curly bracket. Curly bracket made all the difference. Okay. Anyhow, I'm going to shift it down. times collider dot dimensions or size? Nope. Okay. My collider dot, and it's going to have all of the same stuff. Okay, so I'm going to change this to a capsule collider. Oh, I also got to get this. My collider equals get component capsule collider. So now my collider dot height divided by 2 times -1. This is the messiest thing this is the messiest bit of code I have ever written. I'm going to have to make that look nicer. But let's see here. Ah, haha, he jumps now. That is what I was trying to do, right? Yes, that was what I was trying to do. Okay. Now let's make this code look better because, well, just look at it. Yuck. I'm gonna make vector 3 position, or start pose, and it will equal transform.position. Yeah, I'm gonna break it down step by step so it's easier to understand on stream. So first, what we're doing to find the start position of the raycast, we're starting at the object's position, and then we're adding this. Actually, no, we're not adding that, we're subtracting that. We're subtracting a vector that is going in the up direction and is being multiplied by half the height of the collider. Is that more clear? It should be more clear. Well, it's not clear without a semicolon. Now that should do the exact same thing, just looks better. And yep, he jumps now, so that's cool. How much time do we have left? We're going to end at 7. And he disappears into the fog. Oh, that's a good point. I need to see how the fog hides enemies, because this is sort of like a horror-ish game after all. He's jumping. So yeah, you won't see them at all until their sprite is completely out of the fog. Maybe I'll make enemies render like even when they're behind the fog, but then change their because yeah, I don't like how they just sort of pop into existence if you get close enough. So I'm gonna like maybe give them a fade-in effect, you know? Or maybe even, I don't know how I'm going to fix that, but I will fix it at a later date. For now, I need to make him, I'm going to make this guy move towards the player now. And actually, you know what? I'm not going to do that. I'm going to end the stream now. So, nobody was watching anyway, so this is going to be just on YouTube. Anyhow, before I go, or actually, I'm going to summarize what I did in this episode. I'm sorry that this episode wasn't as smooth and directed as the last episode. That will be fixed. But anyhow, this episode we created a dude, and he jumps. That's all. That's all we did in the whole 50 minutes it took to do that. Alright. So I will see you next week at 6 o'clock on Friday. And yeah, see you then. Oh, but before I go, I'm going to update my Git and push it to the Git commit, or to the GitHub. Actually, no, I don't need to do that on camera. Bye.